Welcome everybody to another episode of vBrownBag. I should have turned off my Slack. Anyways, today we're going to be talking about Ansible for network automation, and we have Brenden Peterson at Pete's_Revenge, who I met in New York City, and we were introduced by Nick Squola. So it's really fun to be hosting someone that I actually know. And thank you, Brenden, for coming today. So
thank you, Ariel.
Yeah. Quick notes, if you want to get in on the conversation, we are going to be monitoring the handles vBrownBag, but mostly the Twitter hashtag vBrownBag. If you are unfamiliar with vBrownBag, we have shows almost every day of the week for different regions: APAC, Brazil, EMEA, Latin America. US tends to be the most consistent and the most attended, but wherever you are in the world, we want to hear you, we want to see you, we want to have you present. Reach out to us, and always think about this as, you teaching your other fellow engineers something that you think you dominate well. Our guest again, Brenden Peterson at Pete's_Revenge. I think he had already explained to me once why the handle, so I'll let him explain that again. But Brenden, I'm going to switch over presenter to you, and you can go ahead and start.
All right. Thank you very much, Ariel. My name is Brenden Peterson. I'm a network architect.
I'm not seeing your screen yet.
Oh, hold on. That should do it.
Yes.
Okay. Try this again.
Mm-hmm.
As Ariel said, my name is Brenden Peterson. I'm a network architect for a major media enterprise on the East Coast. We deal mainly with broadcast media. And today I'd like to talk about Ansible and what we're doing and how we're using it for modular network automation. A little bit about myself. I've been with the company now for a little over 15 years, been in the IT industry for a bit over 20, starting as a systems engineer and moving into network, doing traditional data center networking. And then, in the past few years, I've gotten really into development, starting with PHP and moving on to Python. And lately now my focus has been on automation, analytics, and just general data center and WAN architecture for the enterprise. So with that, we'll dive right in. So for the past year or so, we've been utilizing Ansible to help us automate some routine and common tasks.
Brenden, I have a problem. If you switch slide, I haven't seen it.
I haven't yet.
Okay, good.
So yeah, actually. So yeah, we've been using Ansible to automate common tasks within our infrastructure workflows, everything from design and build all the way to operating and maintaining. And throughout the course, we've developed a few helpful utilities to help us, provision network infrastructure, automate change implementation, and help us with some monitoring and analytics management. We've been targeting small portions of infrastructure with big impact and trying to avoid critical paths for major projects and operational workflows. And the main driver behind that is, automating the entire network infrastructure is a difficult task, as I'm sure everyone knows. So we've been utilizing it in small use cases to help aid with the adoption of Ansible and other open source utilities, and just to help make our lives easier in general, keep our configurations and our infrastructure standardized, keep it documented, and just in general, keep our customers happy. With low turnaround times for implementation and design work, And so far it's been great. So with that, we'll dive into a little bit how we use Ansible, why we use Ansible, and go over some of the use cases that we're using Ansible for today. So the main reasons why we chose Ansible, a few of my favorites are the level of abstraction that's offered. When dealing with Ansible, we mainly deal with YAML and Jinja templates, which tend to be easier entry points into development workflows for users that might not be very experienced with scripting with Python or other languages. Another feature is the idempotent nature of Ansible. Once we write a playbook and it's approved, it operates the same every single time, especially on production infrastructure. That's a valuable feature since we know the results will be the same every time we run a playbook, whether it's adding configuration to devices, changing configuration, or building new infrastructure. We can rely on those playbooks to operate pretty much the same every time. Ansible also comes with minimal requirements. It's agentless, so there's no software installation required on remote hosts, which is ideal for network infrastructure. And then also just in general, the user community, the documentation, and other resources available. There's tons of built-in modules supporting network infrastructure, including Cisco, Nexus, Juniper, and then all the way through VMware and other vendor applications, other open source software. So a lot of the heavy lifting for most of the tasks that we use it for has been done already, which is great. So a little bit how we're using Ansible. What we've been trying to do is kind of group our infrastructure into separate components to kind of keep them small scale and standardized. Really what an infrastructure component is to us is a portion of infrastructure that's been designed to facilitate a purpose that is modular and scalable and repeatable. Some examples are data center fabrics. The big one that we're working with today are compute modules running VXLAN plus EVPN. We also have some support for traditional data center models with the 3-tier core distribution access and spanning tree. We've also worked a bit with ACI, Cisco's ACI and their spine leaf topologies. We're also working on support for WAN topologies, including private WAN backbones and DMZ networks. Also what we call external connectivity modules, which help bridge our data center and private WAN to the internet. The way these components operate is different. We can define different types of components like VXLAN, EVPN fabrics, or a private WAN backbone. And those can be replicated in different instances across any one of our data centers or campuses. So they're repeatable. They're also scalable. We can build them as small as we like or as large as we like. And ultimately, they all connect together. In the case of the data center, all of our compute modules will connect into a super spine, which then connects everything into an external connectivity module. And each of those components, you can see on the chart there, is an individual component that has Ansible playbooks written specifically for those compute modules. Now, some of the tasks that we're automating are broken down into, some of the major milestones in the infrastructure lifecycle. So starting with designing new infrastructure, and then provision and testing that infrastructure, and then supporting and operating and maintaining that infrastructure. So to start, I'd like to go over some of the design and build workflows that we've been using. These are generally intended to be used prior to the infrastructure actually being provisioned. So before we actually order anything, we use build playbooks to basically generate configurations and allocate resources to the individual devices in that component. In the case of a VXLAN EVPN network, we can create instances of various sizes with any number of spines and leaf switches, and we have a component builder role, which will go through and allocate IP addresses and subnets, generate host names, and basically any resource that the individual devices within the fabric need. This playbook will generate those variables. Those variables can then be used by other roles or Ansible playbooks to do a number of different tasks, including configuration generation, documentation generation, and then integration with third-party devices. In our case, we use Asinga 2 for some testing, and then Cisco's Power On Auto Provision feature, because we're mainly a Cisco Nexus shop when it comes to the data center. So some examples of how we use the design and build workflows. Basically, the build playbooks operate on a specific infrastructure component, which is defined as a host in Ansible's inventory. This is a little irregular than most Ansible workflows that at least I've seen, but this enables us to work on the component itself and basically instantiate the underlying fabric that the component is made up of. Each component has its own set of variables that are defined in host vars. So we'll be looking actually at a component called Demo Fabric 1, which is a VXLAN fabric, and that's defined as a host within Ansible. And then in host vars, you can see some examples of variables that we're using within that network. So some common variables that are actually shared between all of our components. You can see like our TACX servers, time zone information, SNMP, logging, etc. And then each component has specific variables where we can define specific items specific to that compute module or component. You can see here we're choosing OSPF as our underlay routing protocol. We can specify the routing protocol ID, as well as a few subnets and interfaces to be used in the configuration generation. It's these subnets that will be used to actually allocate IP addresses for those specific constructs. For example, loopback 0 for each of the devices that has a loopback 0, the IP will be pulled from that subnet. And then we also specify a separate file within host vars called tenant variables, which outlines the tenant VNI information for each of our tenants. You can see an example here of two tenants, one being Global Enterprise with its layer 3 VNI information, and then some layer 2 VNIs, and then Global DMZ with the same information below. And that is basically the core of the design and build workflow. These variables are used, again, in subsequent playbooks that can do any number of tasks. So actually, we can take a look at a few of them. See here.
So we had one question. How feature are the Ansible modules for Cisco IOS and Nexus OS? Graham tried them out when basically in version 2.2, assuming Ansible version 2.2, and he said that they weren't that great. What would you say? Have there been improvements?
I would say there have been improvements, yeah. When we first started working with them, we actually ran into some difficulties, especially when it came with using the NX API. Since then, we've had a lot more luck. It seems they've gotten a lot more stable. And they seem to be working pretty well now. We're using a mix of NX API and the I guess the CLI module, which uses standard SSH. And for the most part, they work pretty well. There are some caveats, some gotchas when using the NXOS module specifically, especially when it comes to some of the more in-depth ones, like configuring BGP address families or specific interface information, such as like VRF or other items that can be conflicting depending on the current state of the device. But we've had a lot of luck. We'll see some of those in action.
Awesome. Thank you so much.
So what we have on the screen here is an example of the build playbook, which operates, again, on that component and basically generates the data for each group of devices. So within this component, which again is VXLAN, EVPN fabric, we have module spines, we have compute leafs, border leafs, and super spines. Actually, that should be border leaf data. And what this playbook does is actually uses a lookup plugin that we developed in-house that contains the logic for allocating things like host names, IP addresses, and subnets, and uplinks, or connectivity between the individual devices. What ports are connecting to what subnets do they get, and so on. And we can take a look at an example of the host vars for this fabric. You can see in this particular file, there's a lot of different variables. Again, this is more of a test and lab playbook, so we're a bit widespread. But we go through and we assign specific ports to leaf uplinks, border leaf uplinks, modular spine uplinks, and so on, depending on the model that we're using. A lot of this is statically defined, so it's not going to be something that's intelligent enough to say, it's not going to auto-detect devices and determine what ports are best to uplink. We have to specify it a little bit. And this is actually all comes from standard design documentation that we've produced for this compute module. So every compute leaf uplinks to a module spine, specifically on ports 49 and 50. And the modular spines uplink to the super spines on port 32 of each blade. And then we go through and define some variables for the underlay, including VPC information, management interfaces, BGP information, and so on, Anycast gateway MAC address, and so on. And all of this basically gets used by that build playbook to generate individual variables for each device within the fabric. And what that looks like on the output side is this is an example of that data in JSON. So from that file, once the build playbook is run, we have individual configurations for each device within the fabric. So all the host names here are dynamically generated. And then for each interface that we prescribe, all the configurations for that interface. So you see we have an NVE interface, which is loopback 1, and it contains the net mask, the IP address, secondary IP address, and so on. Same for the BGP interface. And we even have some hardware-based information showing what rack and what rack height, as well as the serial number. So once that build playbook is run, we have these variables to work with, and this JSON output can be used as a source for variables in future playbook runs, or it can be used just for reference. But one of the things that we can do with these playbooks is generate our configurations. So you can see an example here. You see this is the output of some of our stuff from this fabric. And actually right now, let me go through and clean all this out. So, okay, I just got rid of all those configurations. And right now we're going to run a playbook that will hopefully this particular playbook will run that that build play before anything else, basically getting the variables into the Ansible runtime, and I'll go through and run some template tasks to generate the configurations for each type of device. So you can run that, and it's actually going through and generating all of the information, and now it's going through and generating all the configurations for each individual device. So, and just a quick example of how that works. Very simple tasks that are essentially just Ansible templates with a source and a destination. Those templates are Jinja2 and look very much like typical Cisco configs, except for the variable placeholders, which are specified at runtime per device. So now that that is run.
So just to confirm, your Ansible playbook reached out to every device and basically brought their configuration back to you.
No, this actually hasn't talked to any devices yet, and just generated the base initial configurations that will be used for power on auto provision.
Okay.
So before we even have the devices installed, we can generate all of the configurations for each of those devices. And here it configs back again. And now you see the actual config instances for each interface, including, or each device rather, including the BGP configs, the EVPN configs, interface configurations, and so on. Again, these are generated on the fly, essentially from those templates without touching the devices at all. So this is usually our first step for implementing a new data center fabric. We'll put in the necessary variables, we'll assign some subnets, we'll give it some location information, and then run this playbook to generate the configurations. Once the configurations are generated, a little bit further down the line, we'll push those out to a power on auto provision server so that they're ready for zero touch provisioning.
Very nice.
Some of the other things that we do previous to implementation is generate some documentation, which has been really useful for generating bombs, or my personal favorite is cable run lists. So you see the same playbook runs again. First runs the build playbook to generate all the variables for each individual device. Again, since the devices don't exist, we can't talk to them yet. They haven't been installed yet. So now in our output directory, we should have, let's see, nice little cable schedule for everything that's needed to install the fabric. So for each unique switch.
That is pretty neat.
Yeah. Yeah, so that's where the source rack or the rack information comes into play, because we can hand this off to our DC provisioning guys, and they have everything they need to install the fabric, including the serial numbers, the host names, the optic types. We can do a roll-up with a total count of required optics and patch cables. Basically, you know, we can do whatever we want to do as long as we can write it in some form of Python or Ansible. So that brings us to so with that would bring us into the provisioning and testing workflows, which have a little bit different look and feel. They can operate either on that component itself, which is a logical construct of all the devices within that fabric, or on the individual devices themselves. And here we do a lot of provisioning and testing workflows that ensure all the initial configurations get installed, and we run a variety of tests on the provisioned infrastructure. So once DCOP hands off the network back to us, then we can use Ansible to provision and configure power on auto provision. So all those configurations that we just got generated can be pushed up to a POA server. And then we do a little bit of implementation monitoring. So we set up kind of ephemeral Nagios instances that will go through and monitor things like power supplies, neighborships between devices, specific interfaces. We'll run some ping checks across the fabric to ensure that we're not seeing any drops or errors. And then generate some provisioning reports just to ensure that everything is up, serial numbers match, and all the hardware is good and ready to go. We can show a bit of an example of the power on auto provision. So what we're looking at here is our power on auto provision server in a shared directory that's accessible via TFTP, which is one of the requirements for Cisco POA. You see right now we have no files matching our infrastructure in there. And go through and run that quick Ansible playbook, POA.yaml.
So I have a question. First of all, people are very excited, and they're already asking, okay, does he have a GitHub account? And the other question is, are you guys doing, I'll try, I'm not sure exactly what this means. It probably makes sense to you. Do they do any live configuration with Ansible, or is it just POA P configuration?
No, we do live configuration too.
Okay. What's POA P?
POA P is power on auto provisioning. It's a Cisco Nexus specific zero touch deployment system. So each of their switches without a startup config will boot up into what's known as POA mode, where it tries to contact the DHCP server with specific options. And then once it gets in touch with that DHCP server, uses the serial number to identify itself, and then from there can download its configuration. So, and what this playbook just did is it pushed the configurations to the POP server, generated MD5s for each of, or MD5 checksum files for each of the configurations, and configured the DHCP server with the serial numbers and matching them to their specific configs.
That's
so now,
crazy. That's pretty nice.
On that POP server, now we have all the configurations. You can look through each one of them and basically have everything that we need right there. And if everything worked well, we should have a proper MD5 sum. Yeah.
Very
so
nice.
The MD5 sums match, and then our the POP static clients file, which configures basically everything that we need for power on auto provision. So now at this point, the configurations are sitting on the POP server, which is also running DHCP. As soon as our hardware is plugged, the management, or actually any interface on the hardware is plugged into a DHCP capable network, it'll download their configurations, it'll download our specified version of NXOS software, install the software, install the configuration, reboot, and then we're good to go. We have a fabric ready and waiting without actually touching any of the devices. And then, like I said, from there we can do some basic Ansible or Nagios configurations. Actually, I don't have any web interface for that yet, but it's utilizing the same thing, still without talking to any of the devices yet. We're going through and adding all of the devices to a Nagios instance with some very specific checks for the provisioning lifecycle. And once this is done and verified, then we get rid of this Nagios instance. We don't need it anymore. And we move over to a more traditional monitoring infrastructure for the actual operation lifecycle of the infrastructure.
This is pretty neat.
Thank you. So yeah, this is actually some of the stuff we went over. Power on auto provisioning and testing workflows. And then once we're done with provisioning and testing, then we're ready to hand off the infrastructure to operations. At that point, what we're using Ansible for is actually a number of different tasks. In our specific case, we are in the midst of a data center migration. So we're moving production hosts from one data center to another. And Ansible is helping us to generate reports for each of those data centers, both pre and post migration for individual applications, to help us determine where hosts are, how many hosts are in the VLAN, how many hosts are on the switch, and then once they migrate, where have they migrated to, what leaf switch, is everything look valid, is MAC address and IP address advertisements proper throughout the infrastructure, and so on. Some of the other things we do are implement routine changes, which is one of the questions, and we'll take a look at that. And then updating, monitoring, and other third-party systems, and managing the configuration cycle. I think we got some time, so we'll go through each of those. First off is implementing the routine changes, especially when it comes to large-scale changes. So one of our fabrics has 30 plus leaf switches in it, or 32 leaf switches in it, each one being a VTAP. So whenever we add a VNI or a tenant, we have to touch the configuration on each of those switches and ensure it's the same across the board, which isn't difficult, but can be time consuming. So we use Ansible to assist with that. Mainly what we're doing is managing the tenants and the VNIs. So for each change, we supply some basic variables like the VLAN ID, the VNI ID, the default gateway and subnet mask, as well as the NVE multicast address. And then we pass that to Ansible, which then pushes the config across to all the individual VTEPs in the fabric, or multiple fabrics if we have a stretched configuration. And this helps ensure that proper configuration across all of the devices. And then we also use it for general infrastructure updates. So if we add a new TACAC server, or we get some new best practices coming down from whichever vendor we're using, we can actually use Ansible to push those configs to all of the devices, which is kind of a neat feature. It ensures that every device is updated. Sure, a lot of people that deal with large infrastructures know it can be difficult to keep every device updated all the time with proper valid configuration. Let's see, we can actually take a look at one of the implementation playbooks. And so here is one of our routine change playbooks that actually implements or adds a layer 2 VNI to a compute module. You can see the variables that we supply, which is 1, 2, 3, 4, 5, 6, 7, about 10 variables, including the IP address, the net mask, the component that's involved, which actually in this case should be demo fabric 1, and then the state present, which is important. We want to add this, the VXLAN VRF, or the tenant that it gets added to. And then what Ansible does is it loads the credentials and some other connection parameters, like the provider, from saved files that are encrypted using Ansible Vault. And then it loads the fabric settings. And if we choose to, in some playbooks, we have an option to load the output of the build playbooks as well. And that's the those are the variables that contain all the individual IP addresses and rack locations and serial numbers for all the devices. However, we don't need them for this playbook. All we really need is some autonomous system number information to generate EVPN configs, which we'll see later down on. And this is, the rest of it is pretty much exclusively utilizing the Ansible's built-in Nexus modules, and these actually work really well. First, we configure the layer 2 VLAN, then the layer 3 SVI, which is actually a 3-step process. First, we configure the VRF on the interface, and then configure it as a layer 3 interface with fabric forwarding anycast gateway on. And then we actually configure the IP address and mask parameters. And then from there, we configure the NVE interface and then the EVPN VNI configuration. And that we should be able to do. Another feature of the build playbooks is generating a dynamic inventory. So once that's done, we also generate a dynamic inventory which contains the inventory information for Ansible to connect to all the devices. So IP addresses, groups. We group everything into compute leaves or border leaves, all leaves, spines, etc., so that we can do more targeted configurations across the fabrics. And then we'll do the rchange compute module L2 VNI playbook, and we'll supply a vault password, and then hopefully this will work. This is actually running on the same VNI that I ran it on earlier. So everything's going to come back green because it's already been configured. But I'll change some things up a little bit. You can see that completed successfully.
That's very cool.
But now we'll actually go through and make some changes to the device. This has been one of the most helpful playbooks because we have, in some of our fabrics, hundreds of VLANs or SVI or VNIs. So going through and configuring all those was actually pretty easy. We just generated one master variable file and did an Ansible for each. We'll through all of them pretty quickly. You see this just configured a live lab device without issue. Yeah, so on this device we can do a show run and VM 213. See all of our information here. Show on BGP. And BGP. Here is the 12. Here's the VNI information. You can see here it took for the route targets the components BGP AS along with the VLAN ID, which it takes from that initial. The BGP AS comes from the initial settings file. And then once we're done, or if we make a mistake, not that VLAN goes away, we can just change the state to absent, and then go through again. And this is where working with some of the modules gets a little bit tricky, because with especially with Cisco hardware, but any vendor, sometimes order of operations is key. So removing some configs before removing others can be problematic. But again, once the playbook is well written and well defined, usually we don't have any issues. We should be able to go back and take a look at this VLAN. It's no longer there. Look at that VPN. And that specific VNI entry is gone as well. So that's done. And that operates on, fabrics with 2 leaves up to, we've done 32 leaves. And with Ansible's forking, running on, a decent VM, it can push, I think, I should have gotten the metrics, but we did across 32 leaf switches, 30 VNIs in under 4 minutes, which is pretty impressive.
That's much better than doing it manually, for sure.
And then, so beyond that,
I have one question for you here.
Okay.
Are they just doing data center and XOS, or you are also pushing changes out to campus and especially like older devices, iOS devices?
Yes, on both accounts. We started with data center because that's where the opportunity was. We were building a new data center at the time and needed to generate all of these configurations. We needed to do it quickly and push, get basically the fabric provisioned as quickly as possible. So Ansible helped us with that. And as we go along, we're using the same kind of methodology, defining components, doing build playbooks or provisioning playbooks or just support playbooks for various other entities. So Campus is another good example of something that we've been working on. And that will eventually have a complete life cycle from build to provision to operating. And some of the more obscure infrastructures like older data centers or, maybe off-site production labs and that sort of thing, we typically are going to stick with support and operation playbooks for those. But that's what's kind of neat about this modular Ansible use is, we define what we need when we need it, and we try to keep it, as versatile and agile as possible without having to reinvent the wheel every single time. So like these compute module playbooks we've used over and over again now for 3 or 4 different compute modules and a few more on the way. Like I said, campuses will be the next big one because those are easy to define. People are comfortable with them and their architecture. So it's a bit easier to use and get people to adapt on board.
It's very awesome. I'm not a network guy by trade, but I can see the value for sure.
Yeah. In the migration that we have going on now, it's been a great tool. We're running reports by, every 5 minutes to every hour to every night that show us where our hosts are in either our old traditional data center or our new data center fabrics. We're using them to create or to configure some custom Python pollers that we're using to grab metrics from these devices and push them to InfluxDB and create some dashboards with Grafana for log aggregation, hardware inventory reports, which has actually been kind of cool when we deal with vulnerabilities or bugs or anything like that. We can actually run reports looking for specific criteria like a firmware version, software version, or a particular config statement that exposes a particular vulnerability or bug. And then that gives us an immediate report of what hosts are susceptible and what remediation needs to be done. Then we hand that report off to our ops teams, and they're off to the races. The last thing that I have is under support and operation workflows is managing the configurations for these fabrics, which we're using Ansible in combination with Git to back up our running configs nightly and post change, utilizing Git's diff feature and GitLab. That actually gives us a nice view into what configs have changed when and where, which has been useful for validating routine changes implemented by Ansible. We also use it to save our running configurations, just in case someone forgets to do a copy run start, and then back up those startup configurations, which then get pushed back into our power on auto provision system. So our auto provisioning constantly has the most up-to-date startup configs available. So if we lose a device or have to RMA something, all we have to do is swap out a serial number, plug it in, it downloads the configuration, the software version, and is reboots, and it's off to the races.
It's like watching Nirvana here.
Thank you. And it's been fun.
I mean, every vendor, talks about this, but this is the first time that I see someone that says, "Yeah, we do this. It's great."
Yeah, I mean, the key is it's small and it's targeted to what we need it for and what we're doing. So I'm hoping that we can evolve this into more of a framework that can grow and help us manage, more and more of our infrastructure as we go along.
Yeah, you made some fans today.
Well, thank you. And in regards to GitHub, I will be having a presence on GitHub soon. I'll be pushing a lot of these Ansible playbooks as well as some Python code up to GitHub. So keep an eye out.
Will do. Trust me. With when this publishes, people will be asking, okay, where's his GitHub account?
So I better get on that.
All right. Is that your last slide? Do you want to stop there?
Yeah, that's all I got. So if anyone has any questions or wants to see anything, I'm giving.
All right. Well, does anybody want to speak? I can open up the microphone before we end the recording. Oh, we never got why Pete's revenge.
That's well, that's a good question. It's an old family nickname, Pete, that everyone used to call my dad, and then has been toyed around with me. So now whenever anyone calls me Pete, I call it Pete's Revenge. And when I was coming up with a Twitter handle, that was in my head and came out on the keyboard, and that's who I am now.
Sounds good. And do you have a blog, though? Have you put any blog posts about this, or do you recommend anybody else's blogs so people can start reading about it?
Yeah, there's I got so many blogs that I read daily, and I can't think of it. Just to note, a large portion of this came from work that other users have done in the past. So trying to think of, honestly, don't have any blogs off the top of my head, but I am working on one, and I'll definitely be featuring some of my favorites in that. So again, keep on the lookout for both a blog from Pete's Revenge and a GitHub account from Pete's Revenge.
Listen, we'll hold you to it. My best advice, don't worry about making it perfect. Just put the content out there. You can fix the themes and all this later. Start putting content out there, and you'll find that as people read it and give you feedback, you'll put a little more time on it. But don't worry too much at the beginning. Just make sure it gets published.
Right on. Thank you, Ariel.
No problem. All right, everybody. I am in awe. If you're not following Pete's_revenge after seeing this, I can't understand you. And everybody is waiting with bated breath until he posts his blog and he posts his GitHub account, because this was really awesome. I'm sure, most of the people in vBrownBag come from virtualization, but we do have a whole Cisco focused track where we went over some of the Cisco certifications. So anybody looking at the new way of working, seeing someone do it and seeing someone talk about how they did it and how they reused the code and how they, how this made their lives much simpler, it's inspiring. So we're really happy to have had you here today. Thank you again, everybody that assisted and that asked questions, and we'll see you around.
Great. Thank you, everyone.